Already discussed about the core intuition of the dynamic programming, correct? So today we'll see some of the problem statement and we'll try to code it, correct? Fine. Now listen. So first of all, before moving into the directly problem statement, guys, so let me just to quickly revise what exactly the dynamic programming, right? So what is dynamic programming, guys? Right? We know that dynamic programming is what? It is the optimization for the plain recursion, right? Dynamic programming is a kind of optimization to the recursion, and all the recursive code we are trying to optimize using the dynamic programming, correct? Fine. And how to identify or when to use DP? The question is when to use DP, right? So what are the cases, guys, where exactly we are going to use DP? Yesterday we have discussed that first of all, whenever we need to find out or we need to check for the all the possibilities, correct? So whenever we need to check for all the possibilities, correct? Second thing, there will be overlapping subproblems, right? And third, this scenario I told that first of all, you try to solve a particular problem with the help of greedy approach, right? And after applying a greedy approach, if you are getting a wrong answer, then you check that is that question will be solved using recursion. If you are able to, if you think that okay, the question is solvable using recursion, then you will check that this two step that we need to check for the all the possibilities and is there any overlapping sub problem, right? So these are the three ways that we are identifying the problem is a greedy problem or not, correct? And we have seen yesterday one of the problem statement that climbing the staircase and we have seen the problem statement and we have used the method, correct? But if I'm talking about the particularly DP, guys, in a dynamic programming, right, in a DP we have two methods, right? We have a two methods, right? First method is a tabulation method. Right? Where exactly we are constructing a table. The yesterday's method that we have seen is the tabulation method. And second method is memoization. Second method is the memoization method. So particularly we have a two methods in a dynamic programming. First one is the tabulation method and second one is the memoization method. If you remember the yesterday's problem statement, guys, we have given a staircase with the n steps and we need to find out the distinct ways to climb the staircase, right? So let me launch the Jupyter first so that we can try to see the time and space complexity of that one, and we will see whether we'll able to optimize that one by using the different approaches, and then we'll move towards the next problem statement, correct? So let me launch this. See guys, DP is all about practicing these stuffs. So although we are starting with the very basic questions, right? But make sure it will be very handy only when you are regularly practicing the things, right? Otherwise, initial days you feel that dynamic programming is very easy, sir. But every problem you feel that the concept is getting changed, right? So that's the reason I'm telling, please focus and try to apply this technique. The number of questions you solve, definitely the more the concept will be clear for you. So it completely depends upon the total number of questions you are going to solve, right? So we use this approach that we need to climb the staircase. So I'm writing here climbing staircase, same yesterday's approach I'm writing is, right? This is the function and I'm passing here n, correct? Now, what is the steps that, what is the anchor step? I'm writing if n equals to 1 or n equals to 2. In that case, particularly I have written n, correct? And then I have created one list, right? Which is nothing but for the tabulation. I'm trying to store the values in that one so that you don't need to recompute it again for the particular overlapping subproblems. Correct? So I'm creating one list which is equals to, I'm keeping here size, correct, as n plus 1, correct. And we know that by seeing only we can understand that we required an extra list here. That's why the space complexity is getting increased. So suppose I am writing here dp of 1, right, equals to, I'm giving here 1, and I'm writing here dp of 2, right. I'm writing here 2, correct. And then finally I'm iterating the loop. So I'm writing here for, correct, for I in a range of I in a, from where I should start. I will start from 3 to up to where I need to go, guys. I need to go till the n plus 1. Correct. And then what should I need to do? Every time I'm calculating dp of I equals to dp of I minus 1 plus dp of I minus 2. Correct. And then if you try to call the same function for this one, right? So let me call the same function again. If I call the function here for a 4, so what was the answer, guys? For a 4, how many possibilities you are getting for the 4? For a 4, guys, how many possibility you are getting? You are getting the 5. Okay. So you have to get the 5. Let me check. It is getting stuck. Okay, fine. Now the question is what, guys? Whatever the code we have written here, can we optimize that code? Or first of all, let me know what is the time complexity of this code. Anybody? So the code I have written here, I'm asking that what is the time complexity of this code? Order of n. Okay. What is the space complexity of this code? Yes, guys. What is the time and what is the space complexity of this code? Okay, sorry, guys. We need to return now. So I'm writing here return dp of n. Correct. So I'm returning here. Okay. So if I return here, it is giving us 5. Okay. So if you observe this code properly, so we know that we are only using the loop here, right? We are only using the loop here. And if you are using the loop, the time complexity of this question will be order of n, correct? So only the maximum instruction which is taking more time is this loop only, right? And it is running up to n plus 1. So the time complexity in this case will be order of n, correct? And similarly, the space complexity is also order of n. Okay. We observe, guys, if I wrote here plain recursion, definitely we have a two recursive call, which is in the form of expression. In that case, if you are trying to calculate the time complexity, it will be order of 2 power n, correct? So what we are trying to do, we are trying to find out the overlapping subproblem here, and we are trying to store the values of that particular subproblem in the form of tables, and we are using the same value so that you don't need to recompute that function again, correct? This is the strategy, and this method generally we call it as the tabulation method, right? This method we call it as the tabulation method. Now the question is, guys, can we reduce the space complexity to order of 1? Because it is taking n time. So the question is how to reduce the space complexity to order of 1, right? How to reduce the space complexity to order of 1. Same question, guys, listen. Because of what I'm getting order of n space here, I'm getting order of n space here because of the extra list, correct? Because of this extra list only, I'm getting the order of n space here, correct? So guys, if I somehow able to reduce the size here, right, definitely my overall space complexity is getting increase, correct? So what we'll do, guys, first of all, think what we can do. I am telling that we, instead of taking the entire list here, better to take the variables. Take a two variable, guys. I will take a two variable. which will contains the current value and which will contains the previous value. If you observe our scenario, if you observe your scenario, suppose I have a n step in the staircase, okay, you have a two option, either you will come by n minus 1 or you will come by n minus 2, correct? So if you able to store this two value in this two variable, your problem is getting solved. So what I'm trying to say, guys, instead of keeping all the value in the entire list, better to take a two variable and store the previous and current value. So what is the advantage of that? Automatically the space complexity is getting reduced from order of n to order of 1. Okay, but the question is that how we will able to do it, right? So similar way, guys, let me write down, I'm writing here def, let me write down climbing staircase, space optimus, right? I'm passing here n, right? Anchor step will be the same, that if n equals to 1 or n equals to 2, correct? If this is the scenario, I'm returning, I'm returning n, correct? Now, what I need to do, guys, this time I'm not taking the list. I'm taking only two variables here. So that I will able to reduce the space complexity. So I'm taking one variable called previous, right? And I'm taking one variable called current, correct? Now in the previous case, I'm giving the first value, and in the current case I'm giving the second value, right? So this is what, this is when you have a one steps in the staircase and when you have a two steps in the staircase, correct? Now suppose n value is 3, I just need to add these two things, right? We know that whenever there are three steps in the staircase, you have to add these number of steps we required in this. We know that the number of distinct ways required whenever you have a one step in the staircase. Similarly, number of distinct ways when we have a two steps in the staircase, right? So what we need to do is, once we have taken this two variable and once we have assigned the value here, what we will do now? Next, correct? Current. Okay. Anyone? Other answer? First of all, guys, now I already have the first and second, so I will iterate the loop in the same way for I in a range of, correct? Again, I will start from 3 to n plus 1, correct? Up to here I need to go. What I will do, I will take one temporary variable, right? And I will assign the current value to that one, because this current value I need to assign to the previous. So current value, it will become the previous, and whatever the next value will come, that will become the current. So I'm assigning this current value to temp, and I'm writing current equals to current plus previous, correct? And then I'm assigning previous equals to temp, correct? Simple. And what I will do finally, I will return current. I will return current. Now what I will do, I will pass the same case here, that whether it is working fine or not. So let me call the function, guys. Very simple. We are just continuing the yesterday's problem statement, guys. Okay, I will raise the different also, but we'll see the different ways of doing this. So let me pass here 4. It has to return me 5. See. Now if you observe this one, what is the time here, guys? What is the time complexity of this code? Right? The time complexity of this code, see guys, if you take three variables also, the space complexity will be order of 1 only, right? Because number of variable will not impact the space complexity. The space complexity is getting impacted only whenever you require any extra data structures here, right? So in the case of only extra data structures, the space complexity is getting increased, correct? Fine. So in this case, if you observe this one, you are getting the time complexity as order of n, and you are getting the space complexity of order of 1, correct? But guys, if you observe this one, okay, this is also the tabulation way, right? This is the tabulation way. This is what? This is somewhat different logic, right? You can say it's as a tabulation, but it's a optimization to the tabulation, because ultimately we are using here two variables and we are iterating with the help of loops. Correct. Now the question is, guys, can we solve the same question using recursion? Because guys, ultimately here, whatever the approach we have written here, that is not a recursive approach if you observe properly, right? We are simply iterating over the loops, right? My question is, what can I write the recursive code for this one? If we are able to write the recursive code for this one, my question is how? So suppose let's take climb recursive. Okay. So recursive. Huh. See guys, you can submit any of the code on lead code. This both answer will be accepted by the lead code, right? This first one also, this second one also, right? You just go to the lead code, you select Python 3 and you submit. This both answer will be acceptable. And one more solution we'll see, right? With the help of recursion, that answer is also getting accepted by the lead code. Correct. Fine. So suppose I wanted to write this, guys. So how to write this one? Suppose simply I wanted to write a recursive code. What we'll do, guys? First of all, we'll try to write the recursive code, and then we'll try to optimize this plain recursion by using another DP technique, which is a memoization, right? So can you help me to write the recursive code? Anchor step will be same, guys. N equals to 1 or n equals to 2. If this is the scenario, you simply have to return n. Correct? Now, if this is not a scenario, can I write here else and just return the function calls? Is that correct? If I'm using the recursive call here. Is this correct, guys? Suppose I'm writing else return climbing recursive of n minus 1 plus n minus 2. The normal recursive function call, which is your excessive recursion. So I'm writing here n minus 1 plus recursive call of n minus 2. Okay. And let me call this function, guys. Now, if you call this function for a 4, let's check what's the answer this code is giving. See, it is giving 5, correct? But if I'm asking you what is the time complexity and space complexity in this case? Yes, guys. Let me write down here. What is the time complexity in the case of recursion? Come on, guys. Time complexity here will be order of n, and the space complexity here will be order of 1. Correct? Fine. In this case, if you go to the above case, the time complexity and space complexity will be both order of n only, right? So in this case, the time and space will be order of n, correct? So let me write down here order of n, correct? But if you go down, right, this approach is a is not an efficient approach, correct? If you calculate the time complexity, here the time complexity will be 2 power n, correct? Which is taking the exponential time, right? And if you talk about the space complexity here, right? If you talk about the space complexity here, it will be order of n, because we required a stack here, correct? So stack will take the extra space for you, correct? Fine. Now guys, I wanted to optimize this recursion. Okay. So we know that to optimize the recursion, what we need to do? We need to just avoid the recomputation of overlapping subproblems, right? So what I will do, I will take a simple def climb optimize. Just understand, guys, I'm just using extra thing, which is a dictionary, right? But I wanted to write these things by optimizing the recursion. That's the only intention here. Correct? So I'm writing here climb optimization, right? I will take one dictionary. Suppose let me take memoization, right? And what is the advantage of dictionary? Come on, guys. What is the advantage of dictionary? Or what is the beauty of dictionary? Yes, anyone? The advantage of dictionary is what guys? Insertion, deletion, and lookup. All these three operation will be done in order of one time. That is the advantage of dictionary. So I'm simply writing return n. This is the base case of my recursion. Correct? Now, What I do, I have created one dictionary, correct? And every time I'm trying to store the things in a dictionary, right? It's the same like a tabulation only, just only one thing we are doing here. We are doing the optimization over the recursion. That's why this technique we call it as the memoization, right? In the earlier case, if you talk about the tabulation method, guys, it's an iterative approach because we are using the loop and we are iterating from the next value. But in this case, we are doing the optimization over the recursion. That's the reason that we take this technique, we call it as the memoization. So tabulation is a iterative and memoization is a recursive approach. See, it depends on the context of the problem you have to use. You always need to calculate the time and space complexity among the tabulation and among the memoization, whichever you feel that this is the optimal solution that you need to submit. Correct. So I've written here. Now what is the next thing I will do? I will check, guys, if this, first of all, what I will do, guys, if any value, I'm creating a dictionary, right? If this n is present in the dictionary, I will directly return it. Correct. So what I'm trying to say, I will check like this: if n in memoization, right? Memoization is my dictionary. If this is the scenario, then I will simply return what? I will return memoization because I'm storing the data in a dictionary. I will return here memoization of n. Correct? If n is present, right? If this is not a present, we have a same function call. I'm writing here memoization. I'm writing here memoization of suppose n equals to. This will be the same recursive call. Memoization of n minus 1 plus memoization of n minus 2. Right? I'm writing here memoization of n minus 1. Right? Plus I'm writing here memoization of n minus 2. Correct? This is my recursive call. And finally, I will return memoization of n. Correct? And let me call this function, guys, climb optimization. So if I call this function, right, I'm passing here 4. Let's check, guys, what's the issue with this code, or we're getting the correct answer. Huh. So what they are telling that dictionary is a not a callable. So what I need to do now? What changes should I make here, guys? We don't need to do the memoization function call. Na? Sorry, by mistake I had done, guys. Okay. You have to call this function. Right. Sorry. Right. So what we need to do? Instead of doing this thing, I need to call this function. Okay, fine. So let me write down the function. So n minus 2 and this will be n minus 1. Sorry. So if you run this, you will getting the answer. Correct. Now the question is, guys, what is the time and space in this case? What is the time and space complexity in this case? Come on, guys, we have to code the complex questions, right? So if you talk about the time complexity here, you calculate and let me know what will be the time and what will be the space in this case, because this is the optimization over the recursion. So I'm writing here, you write here time complexity, comma, you write here space complexity and let me know. Correct? Fine. I hope guys understood. This method generally we call it as the memoization. And memoization is the optimization over the recursion. Correct? Memoization is nothing but the optimization over the recursion. Clear? So guys, mainly in the case of dynamic programming, we have a two methods. First method, we have a tabulation method. Second method, we have a memoization method, right? So guys, what we have done in the memoization, nothing fancy. We have just created one extra dictionary, right? Because memoization, what it is doing, guys, it is simply doing one thing, that whatever the values you are getting here initially, all the values as you are trying to store in this dictionary, correct? And suppose you are passing the three value here, right? You are checking for the three steps here. What is happening? It is searching that the three is available in the dictionary or not, right? If it is available in the dictionary, you are simply returning that one. That's it, right? If it is not available, it will do the recursive call, because what is our what is our problem, guys? Our problem is what? Here you have a f of 3, right? Suppose let's take, we are calculating for f of 5, right? So you know that one thing, I need to calculate for f of 4 and I need to calculate for f of 3, correct? Now your problem, sub problem will become f of 3 and it will become f of 2, correct? Now here I am calculating f of 3, guys, right? If I am calculating the f of 3, this is stored in your dictionary now. This is your memoization dictionary, right? So this 3 value, for a 3 value, how many distinct ways are there, it will be stored, right? So if you have a dictionary like this, dictionary means key value pair, so you have here 3. For a 3 values, how many pairs will be there, it is getting stored, right? So next time whenever you got f of 3, you don't need to call this function again, you just check it inside the dictionary and return it. That's it. That's the beauty of memoization, right? So what we are trying to do, we are trying to store the data in a dictionary, right? Here, see at this step you understand. I'm trying to store the data in a dictionary, correct? So if the data is directly available in the dictionary, it is directly returning me, right? If it is not returning means if there is a function call, simple, right? So what we are trying to do here, we are trying to optimize the recursion, guys. That is the whole intention, that we need to optimize the recursion, right? So whenever we are trying to optimize the recursion, we'll use the technique called memoization. I hope guys understood everyone, right? For the first time when n equals to 6. Okay. See, if there is a n equals to 6, definitely there will be the recursive call, na guys, right? If you take n value equals to 6, what will happen? This will not be executed. There will be a recursive call for the combination of n minus 1, n minus 2, right? If the data is available, then only it will do the things, right? See guys, what Ramakrishna is understanding is completely different. Because I am telling that if the data is available in the dictionary, then only it is returning, right? Otherwise, every time there will be a recursive call. And definitely, guys, if you are computing if you are computing the function of a 3 first time, definitely function of a 3, function of a 4, function of a 5 is getting stored in the dictionary. So next time you don't need to compute it. That is the advantage of memoization, right? What I'm trying to say, what I'm trying to say, guys, if you are computing f of 6 also, initially nothing will be there in the dictionary, right? You have a f of 5 and you have a f of 4, correct? Now next time you have a f of 4 and f of 3, correct? Fine. Now in this also you have a f of 3 and you have a f of 2, correct? Up to here clear? Now what I'm trying to tell, guys, initially nothing will be there in the dictionary. Nothing. It is empty. But once you started computing these values, you will see that all the f of 3, right? F of 4, right? F of 5, all this value is getting stored in a dictionary, right? So whenever you are computing this portion, right? So all the values are getting inserted into dictionary. Second time what happened? Second times you don't need to call this f of 4 now. You directly see in the dictionary, you will get a value. That's it. That is nothing but the memoization, right? See guys, again I am telling, for understanding the DP, the concept of the dictionary recursion should be clear, right? Because the DP is advanced thing, guys, you know. Once you are good in recursion, dictionary and all this thing, then only you will understand the things in a better way. Let it be fine. See. Now let me raise the second question, guys. Similar kind of a question. And this time you try to give me the answer. Right? So I'm telling that this is a very famous question again. See guys, I have given the different kinds of solution, tabulation method, greedy with the tabulation and all this thing. But You can submit any of this answer apart from the normal recursion to the lead code. It is getting accepted. Correct. Now the question is given a staircase. Same question I'm telling. Given a staircase, right? Where each step where each steps represents the cost, right? Each steps will represent the cost. Determine the minimum cost required. It's somewhat extension to the yesterday's question only to reach the top, right? And the only constraint is what? You can take only either one or two steps. Right? This is also the lead code question, guys. Okay. What they are telling that you have given a staircase where of the staircase, each steps of the staircase represent a cost, and you need to determine the minimum cost required to reach the top, and you can either take one or two steps at a time. Correct? This is the question. Correct. Now they have given a list. Again, this is the list they have given. In a list, there will be a cost. So I'm writing here 10, 15, 20. This is the cost at each steps of the staircase. Correct. So you have a scenario like this, guys. You have a scenario like this. Understand? You have a staircase, right? Assume that this is the staircase, right? And this is your top that you need to reach a top. Correct. So initially, this is the first steps. Correct. This is the first steps. Here the cost will be 10. Here the cost will be 15. Here the cost will be 20. Right. This is the cost assigned to each steps. Right. And after paying the cost only, we can jump to the next step. Correct. So we know that either we can go. This is your first step, guys. By the way, this is the first step. This is the second step, and this is the third step. And we know how to climb. Either you can start from the first step, or you can start from the second step, right? The question is, we can start from the first step. Here only mention, you can either start from the first step or either start from the second step. Correct. And one more thing is, we know that either you can go with the one step or you can go two steps. This is the general scenario of the climbing staircase, right? So they are telling that minimum cost we required to reach the top. The question is, minimum cost required to reach the top. Correct. Now the question is how to do it. Correct. First of all, thing guys, this is a similar kind of question. Only they have assigned the cost here. So could you please anybody tell the approach what we can do here? Yes, anyone, guys? See, guys, we can't do this question using greedy. First of all, those who are telling greedy. Greedy means what? We cannot see the minimum cost and move forward because it is not giving you the solution, right? So what I'm saying that if I'm selecting here cost 10, if you are using a greedy approach, what will happen? So if I'm selecting, because I will select a greedy means what? You have a list of 10, 15, and 20, right? You have a list of this, correct? Now the question is, if you use the greedy approach, I am greedy about the cost, that I wanted to minimize the cost. So definitely among this minimum, I will select the 10th, right? Okay, fine. So if I leave the 10th step, in this first step, the cost is getting applied on me. So 10 plus, correct? Now, suppose I have taken this step, I reach here, right? Now to reach the top also, I have to pass this step now, guys. So what will happen? Again, 20 is getting added into my cost, and you are getting the answer as 30, right? That's why if you use the greedy approach here, you won't get the correct solution. Correct. So that's the reason it's not a greedy approach, right? Means you can solve, but you will not get the exact answer, because greedy means we are always greedy about the cost that we need to minimize. And if you select the minimize cost here, it is giving you the cost, entire cost equals to 30. So we cannot use the greedy approach, right? So no need for minimum subset problem also, guys, right? We will use our general approach to solve this question, right? Okay. So what we'll do, guys, think about the general approach, right? General tabulation or recursive approach, right? So you have a step like this, right? You have a step like this, right? Let's assume that you have a step like this, right? And in each steps you have a value given, correct? So this is the 10th, right? This is the 15th, and this is the 20, correct? This is the 10, this is the 15, and this is the 20, and this is your top that you need to reach a top. We know that this is your first step and this is your second step. So either you can start from the first step and either you can start from the second step. So I'm starting from here. So you know that I can directly reach out to the top by using this second step, and the my cost, minimum cost will be the 15. So in that case, 15 will be the answer for me, correct? Now the question is, guys, now the question is, suppose let's assume that I have a scenario like this, same scenario. You have this one, this one, this one, and this one, right? And here you are getting, suppose, let's take oh, sorry, let's start from here, 10, 15, and 20, right? And this is your top. Okay. See, guys, generally, how you can reach to the top? To reach the top, you have a two ways, correct? Either you go with this way, right? Or either you go with this way. This is the only two ways you can reach out to the top, correct? Now, if you observe this one, consider this is the nth step, right? Consider this one is the nth step. If this one is the nth step, what this one will be? You have a n minus 1 step, right? And what is this one? This is nothing but the n minus 2 steps, correct? This is the logic that we are trying to use here, correct? So if you wanted to reach the nth step, right, you have only two options. Either you can directly go from this steps, or you can go from this steps to reach n, right? So what I will do, guys, I want a minimum cost to reach this one, correct? So initially, guys, suppose I'm asking you what is the cost, what is the minimum cost. Suppose I wanted to find out the minimum cost. So the first thing is, guys, first of all, what is the cost of this one? Right? Let's talk about that. We need to find out the minimum cost among these two, either from this or either from this. Correct? Because I wanted to reach at the top. Correct? And we know that either we can reach from this n minus 1 step or n minus 2 step. Correct? Now the question is, if I'm going from this steps to this step, let's talk about the n minus 2, guys, right? So if you are in the n minus 2, what will be the total cost? The total cost will be the cost of this n minus 2, which is 15, plus how much cost you require to reach out to this step, correct? And can you tell me, guys, how much cost you require to reach out to this step? Anyone? How much cost you require to reach out to this step? The cost will be zero, correct? Because either you can start from the first steps or either you can start from the second step. So you have a cost here, zero. Similarly, if you start from the n minus 1, right? In this case, what is the cost of n minus 1 step? Is a 20. And now the question is, how much cost you require to reach out the 20? Zero, guys. Because either you can start from the first step or either you can start from the second step. So if you observe this one, you are getting 15 plus 0, 20 plus 0. You have to take the minimum from this one, which is a 15. So that's the reason 15 is my answer. Clear, guys? Yes or no? Simple approach. Simplest approach. Everyone understood? Yes or no? Let me know, guys. Come on, guys, because we have to solve the tough question now, right? Fine. Because already we are discussing very basic question, right? Fine. So first of all, okay, you understood the approach. So let me know, guys, how to code it. The question is now how to code it. Same recursive approach, right? Or you can use the tabulation, right? So how to code it? So let's take def minimum cost of climbing staircase. Minimum cost for climbing staircase. I'm passing here what? Cost list, right? I will pass here cost list. What is the first step that I need to write here? What is the first step? You go with the tabulation method, guys. Let me know first the tabulation method, right? How to do this question using tabulation method, right? So what should I write here? Right? First of all, you calculate the size. So I'm writing n equals to len of cost array, right? Because I need to define. Just to go with the normal tabulation method, guys. Fine. What is next? You need to define a DP. I'm writing here DP equals to same yesterday's approach 0 into size. What is n plus 1? I'm taking the size here. Same approach. We know we require the extra space, but later we will optimize it. Okay. So I'm writing here for from where should I need to start now? For I in a range of, okay, come on. I in a range of 2 to n plus 1. Correct. I'm going up to here. What I'm doing every time, I'm calculating dp of I equals to. Now, this is the main thing, guys. What I need to do, whatever I discuss, we need to find out the minimum amount. First of all, suppose you are on the step n minus 1. So, first of all, you need to give the cost of that one. So, I'm writing dp of I minus 1, right? Plus how much cost you require to reach out the n minus 1 step. So, you can write here cost of I minus 1. Correct? This is the first thing, comma. Again, you are on the n minus 1 steps or now. So what I will write, sorry, n minus 2 steps. So what is the cost of n minus 2 step? Sorry, I minus 2 step here. Plus how much cost you require to reach out to the n minus 2 position. So it will be the cost from I minus 2. Simple. Correct? And then finally, I will return dp of n. Correct? And let me take the matrix cost. Those who had already done get this one, please send me the solution for the memoization approach. Send me the solution for the memoization approach. Correct? And let me call this function that I'm passing the cost matrix here. Sorry, cost list here. Guys, I need to return. Sorry. See, you are getting here 50. And could you please tell me what is the time and space complexity in this case? What is the time and space, guys, in this case? Fine. The time complexity will be order of n and the space is also order of n. Correct? Fine. Now I will give you 2 minutes, guys. Please give me the solution. Right? I want the exact code for the memoization. Then we'll see the next question. Time complexity will be order of n and the space complexity is also the order of n. So it is a tabulation again. This is also a tabulation method. Right? So please give the memoization solution for this one. Right? I'm keeping that for you. I'm keeping that for you. Oh, so let me write down the function here. Climbing staircase optimization. And let me write down here memoization. Right? And I'm writing here function. I'm writing here pass. So let me know the solution for the memoization, guys. I will give you 2 minutes of time. Right? Then we'll move towards the next question, which is a knapsack 01. Right. Then once done, let me know, guys. Huh? So let me take one more example, which is a knapsack. See, whatever the questions we are going to see, guys, these are all the basic question of a DP, right? Again, I'm telling there are many more question and many more tough questions in a DP. Right? These are all the very basic questions, right? Just to get the understanding, right? If you are looking for the product base, don't think this much simple question they will ask in DP, right? Because mostly nowadays the competition is very tough, so they are asking the DP in graphs and tree and all these things, right? Yes, anyone? No one? See, those of who don't know, so I'm going to start a new batch on data science, full stack data science and AI, correct? On 13th of November, right? It will be at morning 7:30. Yes, guys, I will upload the notes. I will share the Google Drive's link, right? So that from there you can get the notes. Right? You'll get the notes, no issue. Okay, so this is the very famous question in a computer science, which is a knapsack problem, right? And knapsack means bag. Those who don't know what is knapsack, so knapsack means a bag, right? We have various kinds of knapsack in a computer science. First one, we have a fractional knapsack. Then we have a 01 knapsack, and we have an unbounded knapsack, correct? So I am today we are discussing about the 01 knapsack, but there is a fractional knapsack, right? Those who were in my class, we have already discussed this fractional knapsack, which is a greedy approach, right? Today we are not discussing the fractional knapsack, but similar kind of a story is there, right, in the knapsack. But the approach is somewhat different. Today we are discussing about the 01 knapsack, which is a DP approach, where we are going to use the DP approach. Correct? Now understand this scenario. What exactly the knapsack? Okay. Listen, guys. Assume that this is the scenario of the question. Right. There is one house, right? There is one house, right? And in that house, there is a two partition. Assume that like this, and you have a rooms like this, right? Here is the door like this, and here is a door like this, and here is a door like this. Okay, right. Now the thing is that there is a family living in this house, and they were sleeping in one room, right? Here the sleeping in a room, and here this is another room, and there is a suppose there is a gold available, right? They have stored the gold in this particular room, correct? Now, and they forget to close the door. They slept in this room, right? This door and this door is open, correct? And we have a gold available here, right? So you have a gold in the form of weights, right? So you have a weights, which is a weight list you have, right? And after taking each gold, you will get some sort of profit here. That profit is also there, right? So you have a gold and you have a profit like this, correct? So the question is, and you have you have one bag. That bag is also having some capacity C, right? And this bag we generally call it as knapsack. This bag we call it as knapsack, correct? And as the thief know, there is one thief. He knows that the door is open and he have a bag called knapsack. It is having the capacity C. Now what he go? He went to this room. Now the question is what? He have to feel the gold in this bag in such a way that he will get the maximum profit. Remember guys, he can't put all the weight in his bag because bag capacity is limited. So he cannot put the gold inside the bag bigger than the capacity of this bag. Correct. So what he has to do? He has to put this gold in a such a way that he will get the maximum profit in that. Right. So he has to get the maximum profit in that. Right. This is the problem statement. Correct. And let me write down the scenario now, that what is the example and what is the list and all this thing to you. Correct. So guys, listen. This is the problem statement. I hope everyone understood the problem statement. First of all, guys, we'll try to code this question using recursion, right? And then we'll try to find out the DP solution for this one. Correct. Now, so listen. So you have given weight. This is the one list. Weights equals to, let's take some example. 1 3, let's take 1 3 4 5. This is the one. And let's take a profit, anything, suppose 1 4, let's take 5 7. This is the profit, right? And you have given the capacity of the bag equals to 7. Correct. And what you need to get, right? Because the bag capacity is this one. Assume that these weights are in kg, correct? And these profits are in units, right? Like this. Okay. Remember one thing is, you can't break the gold. Those people who know the knapsack fractional problem, they know that in that case we can break this gold also. But here we can't break. Either you will take the gold or either you will not take. This is the only two approach we have. So either you will take it or you will not take it. Correct? This is the scenario. Correct? Now, the question is, you need to take, or you need to fill, we need to fill a bag, a bag in such a way that we will get maximum profit. This is the problem statement, that we need to get the maximum profit, right? Right, fine. Okay, so guys, first of all, try to write down the recursive solution for this one. Okay, now the question is how to write the recursive solution for this one. Okay, first of all, we need to find out the anchor step to find out the recursion, or to write down any recursive code. Okay, so let's take it, guys. First of all, we'll try to write out the recursive solution for this one. Correct. Now, let's take, we have this two list. First of all, we need to find out two step, guys. One is anchor step, right? And the second thing is what? We have a recursive step. We have an anchor step and we have a recursive step, correct? Now the question is, what will be the anchor step in this case? Correct? What will be the anchor step in this case, guys? Anyone? Anyone, guys? First think about how to find an anchor step means what? Base case where exactly you need to stop the recursion or you need to stop the function calling, right? So what will be the base case in this case? Yes, anyone? Think and tell me. Limit is 7. Limit is a 7. What will be the base case? Assume that, guys, assume that you have a wait list. You have a wait list. Even though you have a profit list. correct? You have a profit list, correct? You already have a wait list, you have a profit list, and you have a capacity. These three are the input for you, right? Assume that, guys, the wait list, nothing will be there. The wait list is empty, right? If the wait list is empty, what you will do? You will simply return zero, because if wait is not there, how you will feel in the bag, right? This is the one case that you will return zero. You will return here zero. Similarly, if there is no profit, right? If your profit array is zero, in this case also you will return zero, correct? And if you are telling that, okay, this if weight greater than capacity, there will be a recursive call, guys, right? For this one, those who are telling, right? Fine. And similarly, if the capacity is zero, right? If the capacity is zero, then definitely it will return zero. It will return zero, right? So this will be our base case of the recursion, right? This, you can say that this will be a base case of the recursion, right? Now think about the recursive step, guys. Think about the recursive step, because you have an option here, right? What is the option here? What will be the option here, guys? You have option here that, suppose, let's take, you have a weight array here, right? And you have a profit list, correct? And you have a capacity C, correct? Now the thing is that when you will feel the weights inside the bag, guys, when you will feel the weight inside the bag, either the weights you are keeping, suppose it's a WI, you are feeling, if the WI, right? Suppose let's take like this, you have a weight called W1, W2, and W3. It is representing the WI, right? So when you will able to feel this weight inside the bag, guys, if this weight is less than or equals to capacity, right? If this is a scenario, then only you can keep this thing in a knapsack, correct? If this WI is greater than the capacity, if this WI is greater than the capacity, you cannot feel this weight inside the bag, correct? This is the general condition, that if you wanted to feel the weight inside the knapsack, this should be a condition. If the weight is greater than the capacity of the knapsack, you cannot feel inside the knapsack bag, correct? Right? But this is not only the case, guys, correct? Because we will only keep that weight inside the bag when it is giving you the maximum profit, right? If it is not giving you the maximum profit, we will not put that weight inside the knapsack, correct? In this case, definitely we will not put, right? But in this case, you have a option that whether you want it to feel inside the knapsack or you don't want it to feel inside the knapsack. These are the two scenarios you have, right? Correct? So by taking this two scenario in the consideration, what will be the recursive function call, guys? Right? Because there will be a two recursive call here, correct? There will be a two recursive. You have a wait, right? And you have a profit, right? You have a wait, you have a profit, and you have a capacity here, correct? Now the first case is what? If WI is less than or equals to the capacity, right? If WI is less than or equals to the capacity, then what I will do? I have a chance to feel that weights inside the knapsack, guys, right? But there is a choice that whether you will feel inside the knapsack or not. Now assume that, guys, you have some data here, correct? Assume that you have some data, correct? Correct. Most of the people are getting very simple, guys, right? Because these are all the basic question, guys, right? Whatever the questions we are discussing are the very basic question of the DP, right? So what I'm trying to say, let's talk about the, wait, let's take the data 1 3 4 5. Let's take 1 3 4 5. This is the data, and the second 1 4 1, 4, 5, 7. This is the data you have. Correct. Now guys, suppose let's start because we need to iterate this both thing. Correct? Right? We need to check this is giving the weight and this is giving, and you have a capacity of 7, and this is your knapsack, right? That you need to fill. Okay. Let's starts with the maximum weight, guys. Here. आप यहाँ से start करिए. Listen. So I'm telling that okay, this is, let's take this weight and let's take this profit. Right? This is the general approach of the knapsack. They are telling that if you keep this weight inside the knapsack, you will get this 7 units of profit. Right? If you keep the 5 kg of the gold inside the knapsack, you will get the 7 units of the profit. Correct? This is possible only in this case when the weight of the gold is lesser than or equals to the capacity of the knapsack. Correct? So what we'll do, guys, we have a two options here. Whether you wanted to fill this 5 inside the knapsack or you don't wanted to fill it inside the knapsack. Correct? You have only two options here. Okay. So how the recursive calls will be looks like, guys? Anyone? Any hint? Because suppose I have included this one. Suppose I have included this one. So definitely I will get some profit. I will get the 7 units of a profit. Correct? So I can write here 7 plus if I'm including. Right? If I included this one, guys, these two things, I don't want it to iterate again. Yes or no? So suppose I'm telling that I included the 5 inside the knapsack. Now remaining size of the knapsack will become 2, right? And the profit is getting added now. Next time what will happen, because this is the recursive approach, the weight will be now 1, 3, 4, because we have included that one, and the profit will be 1, 4 and 5. Correct? And the capacity will be what? Capacity will be 2 now. Correct? Now again I will check this one. If you wanted to include, now you can't include, guys, because the weight is 4 kg and your capacity is 2. Right? In this case, we can't do anything. We just move forward. Move forward means you are taking now weight this and profit this, and again you are passing the capacity as 2. Correct? Now again you will check this weight is greater than the capacity. So you will not take this one, not take this one. You will just pass this one. Right? Now you know that this is lesser than this one. Now again you have a chance whether you want it to add into the knapsack or you don't want it to add into the knapsack. Correct? So this is the general approach to solve this question, guys. Okay. So anybody has any hint to write this recursive call, whichever I told, guys? For example, let's suppose you have a wi is lesser than or equals to, suppose your weights of, suppose let's take, I'm comparing the last one, guys. I'm comparing the last one, so I will take last one will be -1. Right? This is not a anchor statement. This is a recursive. What I will do, I will return simple. What I will return? Uh, I have a two option whether I wanted to include or I don't want it to include. Correct? These are the two options I have. Let's take, guys, suppose I am including. Suppose I am including means what? We want a maximum profit. So I am adding this 7 inside the recursive call. So we know that this last value is nothing but the profit of -1. So what I will do here? I will simply add profit of -1. Correct? Up to here clear, guys? Plus. Once I included the profit, guys, now next time what should I need to pass in the recursive call? This I don't have to consider now. This I don't have to consider now. Now what should I pass in the recursive call next time? Right? Next time I need to pass the weights from this and profit from this. Correct? So what should I need to write now? I will write here knapsack. This is my function call. In that I will write weights. From where I should write the weights now? Because from this element I need to start. I will write here colon, let's take colon -1, right? I need to pass from here. And profit from where? Because I have included the profit also in this one, correct? So again, I will write here colon -1. Or even there, guys, you can write colon -2 because you are starting from the next element, right? And what will be the capacity here? Capacity क्या बना? Capacity will be capacity equals to capacity minus, because we are including this item inside the knapsack, guys. So you need to subtract this item from the capacity. And what is that item? Capacity minus weights of -1, right? This will be there in the function call, correct? But when this one, guys, when you have included the weights, right? If you are not included the weights, then what is? Again, there is a function called knapsack of, right? If you are not included, means what? You pass the, see guys, listen, those who didn't understand, listen. I'm telling that this is only the case when you are included. If you are not interested to include this one, what will happen? You start from here, right? You will directly start from here. In that case, what will be the function call then? In that case, similarly, same thing, that weights colon -1, right? This is just a slicing I'm using, guys, right? Profit, I'm writing here colon -1, and capacity will be the same because we are not including this one, correct? This is my knapsack, correct? And among this, I want the maximum value, so I will take the max of this one. I will take the max of this one. So I'm writing here max of this one. Simple approach, correct? I hope guys understood. Yes or no? If this is not a case, means what? There might be chance that weights of -1, or you can say that Wi is greater than weights of -1. This is a scenario. If Wi is greater than weights of -1, then you can't include, guys. See the scenario. If this Wi is greater than this one, so simply you can't include this one, you will move to the next, right? So there will be only one function call in this scenario, right? What will be that? I'm writing return knapsack, correct? What should I pass now? I will pass here weights, right? I wanted to pass from next, so I'm writing here colon -1, correct? Again, I need to pass the profit. I'm again writing colon -1, and the capacity will be the same, right? The capacity will be the same. This is my recursive call. And simply we have an anchor step that we have already defined. So you can write the anchor step here. This one, if what will be the length of weights equals to 0, or length of profit equals to 0, or capacity equals to 0. In that case, particularly you will return 0. Fine. Understanding, guys? Simple approach. Fine. So let me code, guys, this, right? Let me code this one, right? So let me write down here def knapsack, right? I'm passing here weights, comma. Let's take profit, right? I'm using weights, profits, comma, capacity, right? First of all, guys, I want you people to try first, right? Because I already wrote this pseudocode here, same code here. So without, first of all, directly coding, please try to trace it first, right? This code I have written, right? It's a general recursive approach, guys, nothing fancy, right? We are not yet applied the DP on this, right? We are just trying to write the recursive approach, right? So what I will write, the anchor step will be if len of weights equals to 0, or len of profit equals to 0, or capacity the capacity equals to 0. If this is the scenario, you simply return 0, right? If this is the case, you simply have to return 0. If this is not a case, means you have a recursive call. So if weights of -1, correct, is less than or equals to capacity. If this is the scenario, then you have a two option. Whether you wanted to include that weight inside the knapsack, or you don't want it to include that weight inside the knapsack. Correct. So let's take that. Suppose you wanted to include that weights inside the knapsack. So if you wanted to include means this will be the function call. So I'm writing here. I'm just copying this one. So let me write down. If you wanted to include means I'm writing this is the recursive. Right. And if you don't want it to include, means the scenario will be different. See guys, this is the profit you are adding. Sorry, this one if you wanted to include that gold inside the knapsack, and when you don't want it to include that gold inside the knapsack, right? Now the last scenario is what? Your weights is more than the capacity, right? Your weights is more than the capacity. So this is the scenario that wherever you will find out the WI is greater than the capacity, then in that case this will be the scenario. So let me take here, if your weights of -1 is greater than the capacity, right? If this is the scenario, then simply you will return what this sorry simply you will return the knapsack weights, and you need to write the capacity, right? And what is the input we have taken here? The input we have taken here is this: weights, profits, and capacity. Let me pass it. Before running it, I want you people to trace it once. Guys. Before running it, I want you people to trace it once again. Any mistake in this code, guys? First of all, you digest the recursive approach, guys, because for dynamic programming, you must require the recursion. If you know the recursion, then only you can code the DP. Right? Because most of the scenario we are using. Any issue in this code, guys? Knapsack is not defined. Okay. Where is the error? I did the spelling mistake. Right? I have to write here knapsack. Knapsack. Right? Anywhere again? Here also. Knapsack. Right? Again. Here also. Knapsack. Any other mistake? Huh. Capacity. Spelling, I think so. Huh. So capacity. Where should I need to change, guys? Capacity. Which line number? Anyone? 12th. कहाँ पे change है? This one. This one we need to change. Fine. Return max. Already we are returning na guys here. Any other error? Again, I think so. Spelling mistake. Knapsack. Apart from that, guys, is there any logical error or any coding mistake? Let me know. So you are getting here knapsack last written. Correct. Fine. So knapsack. SACK. This is the profit that you are getting, the 9 unit as a profit, guys. I hope guys clear. Yes or no? This is the simple recursive approach that you have. Right? So you are getting the profit of 9 units. Right? So first of all, guys, I'm not getting that much response. I know that the recursion is somewhat tough. But guys, listen one thing, dynamic programming, backtracking, these are all the advanced concepts, right? Particularly in the case of competitive programming. And again, this same DP approach we are using while coding the neural network, right? Because we are coding the neural network in the recursive approach, because there also we have a back propagation and forward propagation algorithm. And there also I'm using the DP techniques called memoization, right? So that's the reason I'm telling guys, first of all, get hands-on on the recursion, right? I will share one list with you. It will contains the recursive question, right? So be handy with that recursive question, and then we'll try to convert into the knapsack. Correct? Uh, okay, guys. We'll first of all you digest this one, this recursive knapsack, and then probably after that we'll try to convert this recursive approach into the memoization techniques of the DP. Okay, so before that guys, let me give you one more question that you can try. So cutting rod question, lead code, it is also this similar kind of question. It is also this similar kind of question. You try this question guys, this is a very simple question in the DP particularly. This is also the beginner question for a DP, right? Question number 1547 of the lead code. Correct? You have to use the same approach. You can try to solve this question either using tabulation or using the memoization. But remember one thing, guys, particularly whenever you have a standard problem statement like this, right? Because if you know the knapsack, almost you can easily solve 20 to 25 questions on the lead code, because that 20 to 25 questions is based on the knapsack only, right? So we have a patterns here, particularly in the case of DP. So if you know how to write a code in recursion, then only the DP will be easy, right? So my first suggestion is what? Try to write a code in the recursion and then move towards the DP. But I'm hoping guys, whatever the basic question I have explained to you, understood that one, right? So probably we'll continue these sessions guys, and every week, particularly related to the problem solving, right? And we'll try to take, because we were on the DP, so I'm hoping that you people first practice the recursion, and then we'll do this some more question, tougher question on the memoization techniques, right? I hope guys understanding, yes or no, right? And guys, one thing that I already announcing, that I'm starting a batch particularly for the full stack data science and AI, right? Generative AI and agentic AI, right? It is getting started from 13th and it is at morning 7:30, right? So if you are interested, please join the demo classes. It is getting started from 13th, right? Clear, guys? If you have any doubt, guys, please reach out. I will share the notes of this one that you can do, right? But remember one thing, guys, please practice. You required a practice for this one. Correct? Fine. Understanding, guys? Simple. Okay. So we'll take few more sessions on the DP, guys, so that we will try to cover maximum question, and we'll take some of the product based interview questions, right? Because this approach we have to use while coding the neural networks, right? Clear. Hope guys everything is clear, and let me know if you have any kind of doubts, right? Yes, anyone has any doubt, right? So if you want any inquiry related to demo, you can contact with the admin guys, correct? Fine. Fine guys, then bye bye, right? Yeah, bye bye guys, thank you. Let me know guys if you have any doubt. See guys, probably is it NP complete? Yes guys, knapsack 01 is an NP complete problem, right? Fine. So it's difficult to bring it into the follow. I don't want you to mess up the concept of NP hard and NP complete here, but okay, it's an NP complete problem. Fine. So is there any second lesson of a DP? Correct. Uh, yes, guys. Probably will arrange in the next week, and particularly I'm continuing this thing for the my batches, right? Because they are also preparing for the product base, so we are helping them to be good in this kind of coding, particularly DP, backtracking, and sliding window, two pointers, this kind of thing, graphs and trees, right? Like that. Fine, guys. Again, I'm telling guys, please focus. These are the core concept and which we are using extensively in AI fields also. Right? Fine. Okay, fine, guys. Then bye bye. We'll meet.